Hi everyone, and welcome to today's video where we're going to be looking at the electron configurations of ions, or rather how to write the electron configurations of ions using SPDF notation. So the most important thing to learn with this is that it's really no different than what you've learned in the past. When you lose electrons, they come out of the outermost orbitals. When you gain electrons, they go into the outermost orbitals. The only slight trick is with transition metals, and I'll talk to you about those in a second. But for non-transition metal ions, so that is things like your sodiums, your calciums, chlorine and oxygen and nitrogen and all those sorts of things, it's very simple. To form those cations, we lose the electrons out of the s orbital. To gain electrons, form anions, then we put those into the unfilled p orbitals. Now that probably still sounds slightly tricky, so let's just have a look at what it looks like. Okay, so magnesium forms a magnesium 2+ ion. You learned this back in year 10. So the electron configuration of a magnesium atom, 12 protons, 12 electrons, 1s2, 2s2, 2p6, 3s2. All we're going to do is lose those 2 electrons in the s orbital to form the ion. When we lose those 2 electrons out of the s orbital, then we get 1s2, 2s2, 2p6. In other words, it drops down to the same electron configuration as neon, which you would expect to see. Chlorine, as you will remember from many years ago, forms a -1 ion because it gains 1 electron. Remember, it's one short to complete the outer shell, so it gains 1 electron. So all we see, if you have a look, is that in the outermost orbital, it goes 1s2, 2s2, 2p6, 3s2, 3p5. And all we do is we put 1 extra electron into that 3p orbital, and it then becomes 3p6. So that's where that extra electron has gone. So no different to what you learnt how to do in year 10 and year 11 and year 12, where you've gained 1 electron if it's an anion, or 2 electrons if it's something like oxygen or sulfur, or losing an electron or 2 for a cation. Now, where it does get slightly more difficult is when we start looking at transition metals. So when we look at transition metals, then their electron configurations are somewhat more complicated. So transition metals are more complicated because they have the 4s orbital and partially filled 3d orbitals. That's what makes them transition metals. Those 4s and 3d orbitals are very similar in terms of energy level. Okay, but the 4s orbital is slightly further away from the nucleus than the 3d orbital. So that 4s orbital will lose electrons before they come out of the 3d. So if we think of iron, we have the electron configuration of iron, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. If it forms a 2+ ion, which it does, then it will do that first by losing that 4s orbital here. That goes. So we take away that one first, then we can start working on that 3d orbital. And that one, so to get to a 3+ ion, it needs to lose an extra electron, so it loses 1 of those electrons in that 3d orbital, and it goes down to 3d5. So that's the process it works through. Let me show you another one. So let's consider manganese for a second. If you find manganese on the periodic table, it is number 25 on the periodic table. So its electron configuration is going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. Now manganese, you may or may not remember from redox, but manganese forms a 2+ ion, Mn2+. And so to get to that 2+ ion, what it's going to do is we're going to take away that 4s, the electrons in that 4s orbital. They're going to become empty. So when we do the Mn2+ ion, then we get 1s2, 2s2, 2p6, 3s2, 3p6, 3d5. Just like that. That's all there is to know about drawing those electron configurations. Now, a couple of slight tricks. There are 2 exceptions to the electron configuration rule, and they are chromium and copper, and I do suggest you check those out if you're not sure about those exceptions. But this is all I'm going to talk about today in terms of drawing or writing electron configurations. There is always a question on this. This provides the foundation for everything we're going to talk about over the next few lessons where we look at periodic table trends. I will see you for those videos later. Thanks very much.